Hi folks, welcome to 10.3 Hyperbolas. So this is going to be the last conic section that we study. And just to remind you, we've talked about parabolas in 10.1. And that's when we take a slice that is diagonal through one cone, but it happens to go through the base of that cone. We've taken a look at ellipses as well as circles. We kind of snuck that in there as well, and that was in 10.2. And now we're taking a look at hyperbolas, and that is 10.3. So a hyperbola happens when you take a slice out of these double cones, and it happens to go through both cones and the base. And so what you end up with is a parabola on the top and then a parabola on the bottom, okay? Now we're going to take a deeper look as to what it looks like and what it's some geometric notation we can use to describe it, and then we're going to practice graphing them as well. Okay, so let's take a look at this hyperbola. So with a hyperbola, you have a few points that are very familiar to us at this point. We have a center, okay? We have two vertices, okay, one that is here and one that is here. And we have two foci, one that is here and one that is here. And all of those lay along the focal axis. Now, what's important to notice here is that the focus has a greater distance. Okay, so the focus has a greater distance from the center than the vertex does. Okay, so the focus is further away from the center than the vertex is. Now, the distance from the center to the vertex, that distance is still going to be A, just like in the ellipse. And the distance from the center to the focus is going to be C, just like it was in the ellipse. However, for a hyperbola, C is greater than A, and that's going to be important to remember. All right, so we've got two main types of hyperbolas. We can have one, like the top one, that opens side to side, and one, like the bottom one, that opens opens up and down. And in both of these, what we have is we have the focal axis, and we have the center, and then you'll notice that you can take a look at all of the coordinates using A and C and H and K, all right? So we've seen that format before, and again, we'll go over that as we graph them. But there's two other features for the hyperbola that the ellipse and the parabola did not have. And here's what those features are. We've got this, which is an asymptote, okay? And we have another asymptote. So this function actually has two slant asymptotes. And if you look at the one that opens up and down, it has the same thing. It has one asymptote this way and one asymptote that way. And that's going to be part of our drawing, but just like the textbook does here, we're going to use a dotted line. Now I did include, just like I did with the other ones, a table for you to help keep track of all of the different formulas and vocabulary. But the one thing I want to highlight here that is about that C being greater than A is we're going to use the regular Pythagorean identity to help us find our A's and B's. All right, so with that being said, we're going to go ahead and get started with some examples. All right, I find that it is easiest to learn all of these through examples, and maybe by looking at just the formulas we can get too overwhelmed, but once we put it into practice it's actually not so bad. All right, so here comes number 1. I have x minus 1 squared over 9 minus y minus 2 squared over 16 equals 1. Now, when I take a look at this, at first I might be tempted to say, oh, this is an ellipse. Okay? And I would say that because I saw the squared and the equals 1, but that's actually not true, okay? Because there is one key difference here. If we go back up to the hyperbola equation, let's take a look at this key difference. This key difference is there's a minus sign in between those two. And so it is really important that we keep an eye out for that minus sign. So this minus sign means that I don't have an ellipse, but I have a hyperbola. Okay, so from there, let's go ahead and find our center. So our center is going to be 1, 2. Because again, I take the x coordinate and I take the y coordinate, and those two together make my center. I'm going to go ahead and plot that center right now. So 1, 2 is going to be right here. Okay. Now, like before, the numbers underneath the x tell you how far you're going to go side to side, and the number underneath the y tells you how far you're going to go up and down. So we're going to take a look at these numbers, all right? And I'm actually going to write this 9 as 3 squared and this 16 as 4 squared. And the reason why I'm doing that is because I don't want to count out 9 units on the horizontal side. I only want to count out 3 because it's the number squared. Okay? And then from the center, instead of going up and down 16, I'm going to go up and down 4. So 1, 2, 3, 4, and 1, 2, 3, 4. Okay. Now, what I'm going to do is draw the box that will help guide our asymptotes. So I'm going to do this in a dotted line. Okay. And from here we can actually draw our asymptotes. So we've got an asymptote like this. Okay, and then the other asymptote is going to go through the other diagonal. Okay. Now, when we're thinking about the actual hyperbola, the one that comes first in this minus sign, so for example, this x squared, if the x comes first, then it means my hyperbola is going to open side to side. So I can actually draw these branches here. And again, they just kind of follow the asymptote. Okay. So my graph is complete here, but now I'm going to go back and fill in all of the information. So for my vertices, remember my vertices are the ones that are where the ends of my 2 branches are. So where is that on this graph? Well, that's going to make this point a vertex and this point a vertex. And we can write those coordinates by saying 1 plus or minus 3, 2, or negative 2, 2, and 4, comma 2. So for the vertices here, it's not the ones that's further away, but it's the one where the branches are. Now the co-vertices are these points here, okay? So we can say that it's 1, comma 2, and then from 2 we went up and down 4. And so that's going to be 1, comma negative 2, and 1, comma positive 6. Okay, now we do need to find our foci, and that we need in order to have a fully complete graph. So we're going to use c squared equals a squared plus b squared because c is greater than a in this case. And our c squared is going to equal 9 plus 16, or the numbers underneath x squared and y squared. And that is going to give you c equals 5. And what that tells me is from my center, I'm going to go to the right and left 5 units, and I'm going to keep the y value the same. And that's going to give me negative 4, comma 2, and 6, comma 2. And I can mark those off on my graph right here and right here. Now my graph is complete, okay? Earlier I had everything except for the foci, and I want to make sure I have the foci there. All right, last part to this is we're going to go ahead and find the equations of the asymptotes. Now, since you have a graph, you can always count using y equals mx plus b, or one of the equations from above is that it will always be b over a times x minus h plus k. And we can just fill in the numbers from our equation. So y is going to equal plus or minus 4/3 x minus 1 plus 2. And if you want to simplify these, you could, or on an exam, this is completely acceptable as well, okay? So to me, it's more important that you know what to plug in where rather than do you know how to simplify everything. But if you did want to simplify it, let's just talk through what that would look like. We would get y equals 4/3 x minus 4/3 plus 2. That would be one option. Or if we had the negative slope, it would be negative 4/3 x plus 4/3 plus 2. And then I could simplify both of those, and I'll get 4/3 x plus 2/3 for the first asymptote, and the other one would be negative 4/3 x plus 10/3. Okay, let me zoom back out so you can see the whole question on one page. All right, and we're going to go ahead and end video number 1 here and come on back because we're going to take a look at a whole bunch more equations. All right, see you there.